free fall motion. The Earth pulls all objects towards its center through its ever-present gravity. The gravitational force of the Earth causes objects to be accelerated towards its center. The value of the acceleration due to gravity is negative 9.81 meters per second squared. When a body is dropped from a certain height above the ground, meaning it was not thrown and its initial velocity is 0 meters per second, it is under the effect of Earth's gravitational pull and the object is now free falling towards the center of the Earth. The object's velocity will gradually increase according to the formula of final velocity along the y-axis is equal to v sub I along the y-axis minus gt. The object will then interact with the Earth's atmosphere and will experience atmospheric friction, otherwise known as air drag. Air drag or atmospheric friction will cause the object to reach its terminal velocity. Distance traveled by free-falling bodies. We can use the formula in rectilinear motion to calculate for the directed distance traveled by free-falling object. We can do this when we make the following changes. The table below shows the variables used along the x-axis and y-axis and its quantity being described. All the variables along the x-axis will be changed into y. We can now modify the formula for motion along the x-axis as, remember that the directed distance along the x-axis is equal to initial velocity v sub x times time plus 1/2 times a sub x times t squared will be transformed to d sub y is equal to initial velocity times time minus 1/2 g t squared. Assuming that the object starts with an initial velocity of 0 meters per second. The formula above will be d sub y is equal to negative 1/2 g t squared. This is the formula for finding the directed distance along the y-axis if the initial velocity is equal to 0. This formula is used to find the displacement. In this case, the displacement will be the same as the distance traveled by object since there is only one direction of motion and this is towards the center of the Earth. You can imagine that this is a straight line. The table shows the displacement of the object from the origin after t seconds when dropped from a certain place. On the table shown below, in first column, each row shows time t is given in seconds. In the next column, the values of the displacement in meters has negative sign because it is moving away from the origin. In third column, each row reveals the value of the velocity along the y-axis in meters per second. Gravity is ever present and it means that it is acting on all matter. Objects that are thrown vertically upwards are not exempted to the pull of Earth's gravity towards its center. The motion of the object, particularly its velocity, will gradually slow down before it reaches its maximum height, where it momentarily stops in 0 meters per second. We have here the formula for final velocity, which is v sub f along the y-axis is equal to the initial velocity minus gt. At the maximum height, final velocity is equal to 0 meters per second. We can solve for the time it takes for the object before it reached the maximum height. We see that our new equation is t up is equal to initial velocity divided by g. To show the ever-present effect of gravity on all objects, we analyze the behavior of an object thrown vertically upwards with an initial velocity of 15 meters per second. Consider the table below. We can infer from the table that the final velocity of the object as it goes up is slowing down and eventually it stops. When it stops, the object is now solely acted upon by gravity and will fall towards the center of the Earth, with an increasing velocity, but having opposite direction, hence the sign will be negative. The amount of time of an object in upward motion or t up is also equal to the time that it will take to fall down or t down. Since the time to get up is equal to time to get down, the total travel time is t total is equal to 2 times t up, or t total is equal to t up plus t down. Maximum height reached by the object. Any object thrown vertically upwards will eventually and momentarily stop when it is at its maximum height. The final velocity at its maximum height is equal to 0 meters per second. We can solve for the maximum height, or h max, reached by the object by using the formula. Maximum height reached by an object is equal to d up, is equal to v sub I along the y-axis times t minus 1/2 g t squared. We use the value of t up for time t in this equation. So, maximum height reached by an object, h max, is equal to d up, is equal to v sub I times t up minus 1/2 g t up squared. The formula above can be simplified even more by using t up is equal to v sub I divided by g. Now we have the maximum height reached by an object is equal to d up is equal to v sub I squared divided by 2g. Sample problem. An object is thrown vertically upwards, has an initial velocity of 15 meters per second. Find the maximum height reached by the object. Solution. We can use the formula that we have derived earlier to solve for the height reached by this object. We have here, initial velocity along the y-axis is equal to 15 meters per second. We can use maximum height, h max or d up, is equal to initial velocity squared divided by 2 times g. Plug in the values to the formula. d up is equal to v sub I squared divided by 2 times g. h max is equal to 15 meters per second raised to the power of 2 divided by 2 times 9.8 meters per second squared. Simplify. Now we have the value for the maximum height reached by an object, which is 11.479 meters. Finding the velocity of an object thrown in mid-air when it is at a certain height. The object is thrown vertically upwards, so it has an initial velocity. We currently do not know the time at which it will reach the given height. The equation, maximum height reached by an object is equal to d up, is equal to v sub I along the y-axis times time t minus 1/2 g t squared, needs to be modified. We will eliminate the variable for time and write it in terms of the initial and final velocities of the object. Height reached by an object is equal to d up, is equal to v sub I along the y-axis times t minus 1/2 g t squared. We remember that. From here, we can see that time t is equal to. We will expand the terms in the parenthesis and then gather all similar terms to simplify the equation. Get the LCD, which is equal to -2. After simplifying the equation, we see that final velocity along y-axis is equal to the square root of initial velocity squared minus 2 times g times the quantity of y sub 2 minus y sub 1. Sample problem. Calculate for the velocity of an object thrown vertically upward with an initial velocity of 15 meters per second when it is 5 meters above the building where it was thrown. Solution. Final velocity along y-axis is equal to the square root of initial velocity squared minus 2 times g times the quantity of y sub 2 minus y sub 1. Plug in all the given values to the formula. Simplify the given equation. Get the square root and it gives us the answer of final velocity along y-axis is equal to 11.269 meters per second.